Now we're going to look at the equation of a line. So the equation of a line is a rule which connects the x and the y coordinates of all points on the line. Now with a straight line or a linear line, we've got a couple of different forms we will use. So we have the gradient intercept form, which is y equals mx plus c, and m is the gradient and c is the y-intercept. Then we've also got the general form, which you can see two different ways, either ax plus by equals d, or ax plus by plus d equals 0. The thing with this form is a, b and d all have to be integers, and a, the value in front of the x, must be positive. So to determine the equation of a line, we need to know either the gradient and 1 point on the line, or 2 points on the line. So we're going to look at two different methods for getting the equation of a line. Alright, so if a straight line has a gradient m and passes through a point, then it also can have this equation, which is called the point gradient form. Now this is a really good equation to use. It's really simple and easy. And then because you can put your values straight into this and then rearrange it to whichever one you would like to form. So if you need your answer in gradient intercept form or general form, take this one and rearrange it. So the first example, finding gradient intercept form, the equation of the line with a gradient 5 that passes through -1, 3. So we know from this information we've got a gradient of 5, so m equals 5, and a point that it's going through is -1, 3. And so we can just put this information into the equation of a line. So we're going to have y minus b, which is our, so from our coordinate that would be a and that would be b. So you're going to have y minus the y coordinate, so y minus 3 equals the gradient, which is 5, brackets x minus the x coordinates, we've got -1 in there. Then let's just clean that up a bit. So we're going to have y minus 3 equals 5, and then that's going to be actually x plus 1 because we've got a minus and a minus. Now we want to rearrange this, so we just have y equals, we want gradient intercept form, so we want an equation that looks like y equals mx plus c. So the first thing you do is expand the bracket, so we're going to get y minus 3 equals 5x plus 5. And then just take the 3 over. So we'll have y equals 5x, 5 plus 3, which is 8. And we have it in gradient intercept form. Okay, example 2. Find in general form the equation of the line with gradient 3/4 that passes through 5 minus 2. So once again, let's make a note of what we know. So we know that gradient is 3/4. We know it's going through 5, -2, and we want it in the form ax plus by plus d equals 0. So let's start putting this into that equation. So we know that 5 is a, -2 is b. So we're going to have y minus the y value, so y minus -2 equals 3/4 brackets x minus the a value, so x minus 5. Tidy this up, so we're going to have y plus 2 equals 3/4 times x minus 5. Now from here, when we want the general form, we don't want any fractions, so we've got this 3/4, which is going to become a bit of an issue. But because this is 3/4 times by the brackets, which if we wanted to, you could actually rewrite this to look like 3x minus 5 in brackets all over 4. They're the same thing. So to get rid of that divided by 4, we can times the other side by 4. So we'll get 4y plus 2 equals x minus 5. And we've still got to multiply the 3 out the front. Then we can expand our bracket, so we'll have 4y plus 8 equals 3x minus 15, and then just put everything on the same side of the equation, so it equals 0. So we'll have 3x minus 4y, you've got minus 15, and then we're going to have to minus 8, which will give us minus 23. And now we've put that equation of a line into general form. So this is just a lot of rearranging. So you've just got to make sure your rearranging skills are practiced and up to scratch. Okay, another method. So there is another method you can use, and this is really good for the general form. So if the equation of a line with a gradient of a over b has the general form of ax minus by equals d. So your gradient actually goes straight into the formula. So your a value is the numerator, so it goes in front of the x. The b is the coefficient of the y. Now notice in the general form it is a minus. So if the gradient is positive, there's a minus in the middle. And in the second part, gradient is negative a over b, then you have the general form and it's actually a positive in the middle. So that's just the part you have to remember. So this example, we've got find the equation of a line with a gradient of 3/4 and it passes through the point 5, negative 2. So from here, if we've got m equals 3/4 and it's got to go through 5, negative 2. So if we're doing this, if you look at that rule up the top there, it's positive gradient, so we're going to use the first one. A is the value at the top of the gradient, so it's going to be 3x, minus the value at the bottom, which is the b, so that's 4y, equals d. Now once we've got that, we just have to sub in the point we've been given for x and y to work out what d is. So remember, this would be x, the power would be x, and negative 2 would be y. So we'll have 3 times 5 minus 4 times negative 2 equals d. Work that out and you'll get 23 equals d. So the final equation will be 3x minus 4y equals 23. Then if you wanted to write it in the form where it equals 0, then you can just take the 23 to the other side to make it equal 0. And now if we look at b, where we have a negative gradient here. So for b, our gradient equals negative 3/4, and our point it's going through is 1, 7. So we can put it straight into the formula. So now because the gradient is negative, so we're going to have 3x, because the 3 on the numerator. Because the gradient is negative, this equation will be positive in the middle. The denominator, which is 4 times by y equals d. Now we want to sub in the 0.17, so we'll have 3 times 1 plus 4 times 7 will equal d, which will give us 3 plus 28, so 31 equals d. And then we put that back into the equation, so we'll have 3x plus 4y equals 31. So that's another really quick way of doing the general form when you've got a given point and the gradient. Now last example, we have a circle that has a centre at 2, 3. Find the equation of the tangent to the circle with a point of contact, negative 1, 5. So we're going to draw a diagram of this. So we have been told we have a circle. Nice lovely circle there. It has a centre at 2, 3. So the middle of the circle has the coordinates of 2, 3. And the equation of a tangent to the circle with point of contact, negative 1, 5. So the point of contact is to the left of that point, and it's going to be higher than that point. So it's going to be somewhere around here. Doesn't have to be exact. All right, it's a tangent at that point. So remember, a tangent is a line that is outside the circle that touches the circle at one point. So it's going to touch the circle at that point like that. And then this point here is negative 1, 5. Now we want to find the equation of that line. All right, so if we were thinking about this on coordinates, to find the gradient of that line, okay, first of all, we need to find the gradient between the 2 points. Because if you look, the tangent and the 2 points, those 2 lines, you will find are actually perpendicular to one another. So the first thing we have to do is find the equation of this line. So we'll call the centre C and we'll call the point P. So we want the gradient of CP. So we want y2 minus y1 over x2 minus x1. 5 minus 3 is 2, minus 1 minus 2 is negative 3. So the gradient of the pink line there is negative 2 over 3. Now the tangent, if you look, is perpendicular to that line. So the gradient of the tangent, so I'm just going to write the gradient of the tangent, is the negative reciprocal of that. So because the first gradient was negative, the tangent will be positive, and then we flip the fraction, so it'll be 3 over 2. And I want the equation of that line, so we can just sub the values into either of those methods that we did to get your equation. It doesn't tell you what form the equation has to be in, so you can just pick whichever one. And remembering the tangent is 3 over 2, and the point that it's going through is negative 1, 5, so that's the point we'll be subbing in. So I'm going to use this. I'm going to use the form where we went y and minus the y value, so that would be y minus 5 equals the gradient. And then we have x minus the x value, so it'll be x minus minus 1, which will give us plus 1. Now from there I can leave it like that. I can rearrange that to the general form. I can rearrange it to the gradient intercept form. Because it hasn't told us how to have our answer, I could just leave it like that as well. All right, that is the end of that content. So that is exercise 9E from your booklets. Have a go at those. There may be some interesting ones in there if you just have a go and a practice. Draw some diagrams if you need to, like with the circle questions. Generally a diagram will really help. And if you have any issues, just send your teacher an email and they will help you when they can.